talk about what is actually Indian grid, how there is a electrical power system starting from generation to distribution, then how is a EHV substation, and in that EHV substation, how there are auxiliary systems, and all these we will discuss. First of all, we know that our Indian grid, it was actually in 1991, there were five regional grids were there, who were operating with their own frequencies, means five regions were operating with other different frequencies, means there was some variation in the frequencies, they were not synchronized. In October 1991, the eastern and northeast, that this part get synchronized. Later on, again in March 2003, this eastern, northeast, and the, we can say, western region become synchronized. Later on in 2006, northern region were get added, and in this way we form this grid. But still up to 2013 December, the southern region was operating asynchronously. So in December 2013, with the installation of 765 kV line from Solapur to Raichur, so this southern region we have synchronized in 2013. So this is a brief idea about our Indian grid. And we all know that our generation, transmission, and distribution system. We know that power generation is at that is a low voltages, that is 11 kV, LT voltages 11.5, 12, or sometimes 13 kV also. Then we step up these voltages at EHV level. Then we transmitted those voltages. Generally, EHV level started from above 33 kV. So 66, 220, 100, 400, 765 kV, and so on. So like that, 765 kV and like that. So there are so many voltages. Also in transmission, there is a role of HVDC also. For power transmission, we use, for specialized application, we use HVDC. Later on again, we have step down substations. Again, we step down those voltages at again at high voltages, and later on again we step down those voltages for the primary distribution, and from this primary distribution again we step down to the secondary distribution, and in this way we get power at our home. So this is the journey of our power from generation to our end. Now EHV substation. So these are extra high voltage substations where we can say that there are so many arrangements of, that is a single bus arrangement, double bus, 3-bus system. There are gas insulated substations. There are 1.5 breaker scheme. Those substations are also there. So in EHV there are so many stations, even HVDC also. And nowadays again we can say that recent trends in transmission, that is coming new technologies like voltage source converter based HVDC and so on. So today we will focus on our EHV station. So in EHV station we know that there are buses to connect all the equipments of that bay. We have isolators, we have circuit breakers, then we have series in CTs are there, again line side isolators. So such type of arrangement is there in our EHV substation. But to maintain this substation, we need auxiliary supply system. So there are two auxiliary systems in any EHV substation, that is AC supply and DC supply. So AC supply you need for operation of the circuit breakers. Then even you have some motorized operated isolators, air conditioner, your lighting system, So there are so many uses of this AC supply in our EHV station. But we have to maintain that supply, AC supply, and there should be redundant supply in our EHV substation. And again, to provide more redundancy for this, we provide DG sets also. So means we ensure this backup to AC and DC supply, because if this AC supply, auxiliary supply, whether it is AC or DC, is not available, then you are helpless to run your this power, we can say your EHV substation, because there are operation of the many breakers. These are pneumatic breakers which compressor needs to run to maintain the pressure of the air. So for that you need AC supply. For motorized operation of the isolators, you need AC supply. For air conditioner to maintain the cooling in your substation for the healthiness of all the equipments, you need this AC supply. So means to maintain our EHV station, we want auxiliary supply, AC and DC. So today we will cover this all the aspects. What are the auxiliary system we needed to maintain any EHV station? So we have this AC power supply substation. So generally we see it may be your 22 kV feeder that we brought on this double pole structure. So there are some transformers, either it may be mounted or it is kept on plinth also. So we have isolators and all those things. That is air brake switches are there. So this is the all arrangement that we generally look whenever we see any double pole structure for a distribution side. Also nowadays there is a new trend that moving these distributions substations are coming. Just I shared for your knowledge, as we know that there is as we can see that for communication there are certain towers, moving towers they are using. In the same way now people are using these moving stations also, distribution station particularly. So just for to know this, I shared this aspect. So we will look for the AC system now. In AC system we have AC distribution. For that generally we take any feeder from 22 kV, 11 kV, and then we use distribution transformer there, and that 11 kV we step down into 440 kV phase to phase, and single phase when we take it is a 230 or 220 volt AC. And this is the again auxiliary arrangement. Whenever you go to any AC that is EHV substation, you will find out some of the feeders, because you want different feeders for different equipments. So you divide all these AC supply, and it is also again we create backup also. Means for supply particularly to the AC supply to any breaker, we provide two feeders. So one is main, another is backup. So generally we provide two supplies. Also there are some LT breakers also, that rack out type breakers that we use for this distribution of AC system. So these are the AC distribution boards that we use indoor. Then we have auxiliary supply arrangement is like this in any substation. Generally, there are some transformers like 50 MVA transformers that generally maybe its primary is loaded for maybe 220 kV or 100 kV or 132 kV. So that primary, even you can load the tertiary of the ICTs, that is interconnecting transformers, that is 400 by 220 by 33 kV. Even that 33 kV tertiary you can use as an auxiliary to supply the auxiliary power to your substation. So that also you can do. And some transformers like some of the transformers like 220 by 22 kV or 100 by 22 kV, like that. So this is the arrangement of one particular substation. So I have given it just for an example. So we have 50 MVA transformer, which is a 220 by 22 kV transformer. So there is an isolator. Then this is a bus, we can say, and this is a bus coupler, which connect two bays. Means to connect these two sections, we have actually bus coupler. Then we have again isolator. After that, we have this transformer, and this transformer converts this 22 kV whatever incoming came from the power transformer, that we convert into, that is the low voltage, that is we can say 440 volt. And then we have again here for the protection purpose, we have circuit breaker, we have transformers side, means line side isolator we have. Then we have AC distribution board. That way I have already shown you in the previous slide. There is a AC distribution board where you are actually all these you divide this AC supply for the different feeders. Like here I have shown some feeders like 400 kV yard lighting, 220 kV yard lighting, main source. Then you provide this incoming source for the chargers also. Your chargers are actually AC to DC converters. So you provide AC supply to this as an incoming, and then you will get the output of the charger in the DC. So for the communication we have 48 volt chargers, and for the protection and control we have 220 volt chargers. Again, we provide this AC supply to the breakers and even isolators also when there are motorized operated isolators. For air conditioning and for indoor lighting and even panel light, even control and relay panels also, there is a arrangement of AC supply. So everywhere we provide this AC supply. Also, there are so many other distribution feeders also. As per the application, we divide. Generally, we make the arrangement like that. So for every equipment, there should be two sources. If one source fails, other should take over. So that should be the auto change or arrangement also. So this is the bus coupler. Even suppose this breaker is not working or any equipment here in this it is not working. So if it is issued with this, then I can close the bus coupler and I can feed this power supply from this bus coupler to the other feeders also. So this is the redundancy provided in AC auxiliary supply arrangement. Again, we have some main LT panel. So from that main LT panel, this supply goes to the, we can say, just a minute, slides has been missed. Yeah. So from this LT supply, actually that supply goes to these ICTs, even we can say cooling system of the transformers, then the pumps of the transformers, that also runs on the AC supply. So for the running of the cooling, that pumps, even fans, we need AC supply. So everywhere we need this AC supply, even street light, yard lighting, everywhere we need such supply, and accordingly we divide this supply. So this is the arrangement of this supply that already I have shown in previous slide. Generally two sources, and these isolators are closed, then closing and opening. These are the some of the positions are shown. So generally we provide this backup arrangement whenever we supply AC power. So this is the arrangement of any EHV substation. If we design any EHV substation, we have to physically actually locate all these even control room, then relay room, PLCC, that is a communication room. So this is the arrangement. Just here it is shown. Here we have, these are the equipments in a, this is the outdoor system where all the equipments are arranged, and in outdoor, and in indoor we have these are protection panels. Then we can say protection, that is a protection panels are there. Even in there is a control room. So in control room, we have these control panels. And for the communication, we have telecommunication room where maybe there are different types of communication arrangements are there. Like we have PLCC communication, fiber optic communication, then RF radio frequency, multi-site. So there are so many ways of communication. Even VSAT also we can use for the data uh, transfer. So these are the this is the arrangement of any station. Now the most important part to maintain the auxiliary system. And whenever you maintain any auxiliary system, you have to take care of safety. I always suggest, or especially I recommend to every electrical engineer, and even to the just graduate or who are learning, I always recommended you to be very careful about while working in any station, because we are playing with the live system actually. So you should be very cautious about whenever you do any work. My first that is a advice to all of you to work with safety, because life is most important. So for that, safety precautions should be taken while working on any EHV station. It might be your low voltage site, or we can say it's a distribution voltage 220. And suppose we can say that it is a very low voltage, what can happen? But if many things can happen, even only some milliamps of current is required for our death also. So I always this suggest or advise to you to be very cautious whenever you work in any substation, whether it is generation, transmission, or distribution, anywhere. So we will look up this about the maintenance of auxiliary system, how we do maintenance of the auxiliary system. So we have DG set that we have to maintain. We have to ensure whether, suppose I have two auxiliary sources, but I have never checked whether this, suppose my one source went out and other source will cannot stand, or maybe two sources get hampered and my DG set will not come. So what will happen in the station? So I have to always ensure the availability of my each and every auxiliary equipment. So for that, I have to ensure my DG generator set. For this, weekly we have to take the trials of DG set, whether it is working or not. Whenever I interrupt any source, just suppose my one source interrupted, at the same moment my DG set should start, so that I will come to know that my DG is now ready to take the load. So that precaution I have to take. Then ACDB maintenance is there, AC distribution maintenance, whatever I have shown you. There are some LT breakers and also some feeders are there, some contactors there are there inside. So we have to clean those contactors, because many times due to continuous operation, there is a melting of contacts. So that there is a carbon deposition. So there is a loose connection. Because of less loose connection, it may result into the even flashover inside that panel. So that precautions we have to take. Then I have to ensure the maintenance of my distribution transformer also, and circuit breaker maintenance, that whatever use I have used. So this is the DG set we have at this 400 kV station to cater the load whenever two auxiliary sources are not available. In that emergency case, it should cater the complete AC auxiliary load of the station. So that rating should be have your DG set. Then advantages, we know that DG is it can say that it is available in emergency. We know that whenever any grid fails, there is a we hamper actually to start our EHV system because of not getting reliable source from any station. So in that case, DG plays vital role because it keep your auxiliary running, so that the pressures of that compressors, whatever pneumatic breakers you have, so that pressure will kept in that proper condition. so that your breaker should be ready. Otherwise, if that pressure get dropped, what will happen? Your breaker will go into the lockout and that breaker will not operate in the emergency situation. So DG is most important whenever we maintain the AC supply in the station. So maintenance of DG sets, already talk about it, that we need to take that is a weekly trials. Even we have to take the readings of that. We have to check the fuel, whether diesel is available or not. It may happen that sometime diesel is not there and it will not run. So that also we have to check. Also we have to check the control mechanism, whatever control design for this. So my DG should come whenever there is an interruption of any source. Suppose that source tripped, it should come into the service. That control circuit also I have to ensure. So these are the aspects of DG set. Then this is the AC distribution board that also I have to maintain. That is we maintain it in quarterly or annual maintenance we do. We rack out each feeder. There are backup feeders we have. So we rack out feeders and then we clean all these contacts. Even these LT breakers we have to maintain. We have to check the gap between the contacts because contact melts due to the number of operations and the heating. So that contact gets melt. And if there is a especially some gap remains, so there is a starting of sparking in that gap, and because of that there may be the chances of flash over. So to avoid that, we have to ensure the maintenance. So annually we maintain these breakers, and also individual feeders also we maintain. Also we have to check the earthing system for these panels. Earthing system everywhere you have to ensure, whether it is EHV equipment or your distribution. So we have to ensure the earthing, because if there is a fault is there, so that fault current should go into the earth. So that care we have to take. Again, we have these distribution transformers. For distribution transformer, we generally people neglect the distribution transformers. So why in distribution there is a failure of number of these distribution transformers? Because we never care for their maintenance. So we have to check the oil level of that. There are so many leakages are also there for the transformers. So for applying special type of material, that is special putties are there. So that putties you can apply. Even cold welding type, those things you can apply for the leakage. You can attend the leakages so that oil level can be remain maintained. Also, sometimes you have to check the quality of oil also. That is, at least you should take the BDV of this breakdown voltage. That you have to check. Take the sample of this oil and check there is a BDV kit, breakdown voltage kit. Just take the sample and check the breakdown voltage. So from that also you will come to know the quality of the oil. Generally for the power transformers, we test the oil in after certain period, but for distribution transformer we never check, and it is costly also. But at least we can check the BDV, breakdown voltage, so that healthiness of this transformer oil can be checked. Also we have to check tighten the connection, vibrating parts and jumpers. Because we know that in electrical, whenever there is a fault in electrical system, it results into the electrical disturbances as well as mechanical vibrations also to the equipments. So those vibrations we have to take care, because of sometimes there is a loosen, some connections get loose. So that you have to check. Also there is that jumper, that is those aluminum strips are there which are making connection with the conductor. So that also we have to check. So these are the aspects of maintenance of a distribution transformer. Then LT breakers, that is rack out types of breaker that you have to maintain. These are the those breakers, some mechanical arrangement. There is a spring arrangement. There is a closing coil, opening coil. So these are the provided. I'm requesting please mute yourself who has unmuted. So just from here, one thing you can observe from here, Uh, Here you can see what is the safety aspect you can observe from here. So I'm personally advising you, you should not work like this. See here, no hand gloves, no helmet, nothing is there. Just he is working on the equipment. So how we should work with all your PPEs, that is personal protective equipments you have to use whenever you work at any voltage level. You should take care of all these things. So just you can see the difference between these two things. So always remember that we should work with full safety. So here these are the already seen, we have aspects of these, we have to take the trials of this, whether this closing coil, their opening coils are operating, spring charging mechanism, then sometimes motor gets disalignment, or sometimes it gets the screw gets broken sometimes, so that you can connect and proper alignment of that motor which is operating the spring, so that you have to do. So these such types of then tightening connections and all those things you have to do in the LT circuit breakers. So now we will look after this DC supply in the EHV substation. So how is the arrangement of DC supply in any EHV substation? Generally, for the control and protection, we have two charger system. And for the particularly for the communication, we have separate charger system. It may be one charger or it may be redundant charger also. If it is a more important substation, then there is a redundant charger for communication also. Here we have chargers, how the charger and these load and battery systems are connected. That is actually parallel connection. So here we have one charger. Here this is another charger. Actually in any station, we provide two different DC sources. So that should come from the two different DC chargers. Generally in running condition, we feed this DC supply or DC power to the, actually it is from independent charger. Means every feeder there are two DC sources coming from the two different chargers, but all arrangement is in parallel. And for the communication, you will have 48-volt battery charger, where you use here for the your communication, voice communication, as well as data transfer, and for the again another systems, like you can use it for the SCADA system also, that 48-volt. And here 220-volt is used for the control and protection. So here we have this DC distribution arrangement. Here here bus coupler is given. Suppose one charger failed, so I can extend this DC supply to other. So that backup means this arrangement is given to extend the DC supply to the another system. So this is the auxiliary DC supply. In auxiliary DC supply, this is your charger, and this is battery set, and this is a load. So all these work in a parallel. Suppose my charges get failed, still my battery will take care of this load. So battery has certain capacity, so it will run for certain hours as per its capacity. If 200 Ah battery is there and I'm running with the 20 amps DC current, so it will give its power to up to 20, we can say 10 hours actually. So that is the capacity of that battery. So here we can say that battery is actually backup. Generally, normally we provide our DC supply through the chargers, and battery as a just a backup. Whenever this fails, then battery will take care. But it is not like that. You should not check your battery. You have to maintain this battery. Otherwise, in emergency condition, this battery will not be available when there is a failure of charger. So for that, you have to ensure the maintenance of the battery, regular maintenance. So that will also, we'll see that how we can do it. So this is a general arrangement of this. Generally, we have this three-phase supply. From there is a transformer. So that transformer reduces that voltage, and it feeds to the rectifier bridge. Generally, diodes. Previously people were using diodes. Now later on in middle, so this thyristor based technology came, and now there is a new trend that came into this charger technology, that is a switch made power supply that is based on the IGBTs. So now they have replaced these thyristors because of the modular form, its compact technology. So this is the arrangement here. So generally these chargers we operate in the parallel, batteries in parallel and load is also parallel. So all these arrangement is in parallel to maintain the redundancy of the system. So this is the DC distribution arrangement. You have positive bus and you have negative bus, means negative bus, and here negative positive. So here your load where you provide one positive and other negative terminal, and from that you supply to your actually other systems. So this is the DC distribution arrangement, means one positive and one negative, that 2 wires we take to each equipment for control and protection. So this is our auxiliary DC supply arrangement. So I have I have taken the one case here. Here it is a 220 volt charger. This is the inside view of this. So this is our actually silicon control rectifiers, that is thyristors are here, which are fitted on the heat sink. To absorb the heat from the thyristor, the heat sinks are provided. Then protection for this thyristor, that is fuses are provided. Then this is a transformer which actually feed our AC supply, is step down AC supply to the input of the charger. Then you have some indication, you have some feeders from this. So such arrangements are provided. Then special importance is earth leakage. Earth leakage in DC is most important. You can't ignore DC leakage, otherwise it will take hamper your whole system if there is a leakage of the DC. So for that, earth leakage relay is also provided here in this charger, and these are the all indicators are provided here. So here we have in particular station 220 volt 2 chargers of 26 meg, and 220 volt it's a 300 Ah capacity, ampere hour capacity. And other is a 48 volt PLCC charger, that is 1000 Ah capacity, because the loading of this 48 volt communication is more. So that's why we want more capacity of the battery for the particular communication. So these are certain, and this makes may be different in any substation. So this is the internal structure of this, how these connections are there. Whenever you feed load to the battery, this is the internal arrangement of that charger, registers arrangement. Then you have this thyristor, this is a transformer. So like this is the arrangement of the battery charger. Then we have certain indications to know the operator or the condition of the this charger, healthiness of the charger. We have some indication, that is AC failure, DC fuse failure, this is a boost failure, float failure. What are these indications? AC failure means whenever AC supply goes, so then it will blink. So you'll come to know that there is a AC supply is not available to the charger. DC fuse fails. These fuses are used for the protection of the thyristors. So if it is blown out, it will not give you the proper output. So then you have to replace that fuse. Then boost and float, these are the actually modes in the charger. Float mode is generally we float mode we operate in normal condition, but whenever I have to charge the battery with certain current, then I have to go for boost charging, under voltage, over voltage, and earth leakage for the DC leakage. So these are the some of the alarms. And this is the again the arrangement of that relay, how it is connected in between positive and negative bus. So that we have shown here, earth leakage relay. So it will ensure whether your positive is earth or negative is earth. So that will indication you will get on the panel itself. So battery important is most important. Battery chargers and distilled water plant, DC distribution board, that all these auxiliary systems you have to maintain. So this is the lead acid type batteries. It may be horizontal connection or it may be this connection, vertical connection to if the space is less, then you can go for such connection. So this is the arrangement in substation batteries. As per the substation voltage level, you can go for the different types of battery. Like 33 kV, you will have only 30 volts, 132 kV, 110 volt, 220 kV, 110 or 220 volt, 400 kV, 220 volts. And for all communication, you use communication and SCADA, you use 48 volt. So this is the arrangement of a battery in different voltage levels. So these are the series connected actually these cells series connected means positive is connected to the negative of the other like this. Positive is connected to the negative of means series connection. Each cell is a generally 2 volt battery. So for 220 volt you want 110 number of cells in series. Then you will get the output of 220 volt DC. So substation battery, if you see, it is the heart of substation because we cannot rely on AC supply only. If AC supply fails, charger fails, then naturally your control and protection supply, that is DC supply, is rely on your battery system because control and protection is most important aspect for any EHV substation. So that's why our battery is the heart of substation whenever emergency comes. So it is a process where electrical when we charge means electrical energy is converted into chemical energy, and when we discharge, chemical energy gets converted into electrical energy. So we have different types of cells like primary or secondary cells like that. Functions, switching operations, indications, energizing and holding operating coils of circuit breakers, interlocks, relays. So for this we require DC. PLCC and SCADA we required DC. For emergency lighting, whenever AC supply went out, so we have to actually our certain load, essential load goes on battery, lighting load also. So for that we want emergency supply. And voltage goes 2.15 to 2.2 volt, healthy condition of the battery, and specific gravity goes into the range of 1185 to 1210 at 27 degrees Celsius. So these are the specific gravity of the, we can say particularly what is the content of that acid as well as the electrolyte. So that is the that quantity we can ensure with the help of specific gravity of the battery, which will give you the idea of how much battery is charged as per your specific gravity. Then we have battery pads, that is positive and negative plates we have. Then we have separators like rubber, plastic or iron in between the positive and negative plates. So positive plate is for the lead acid battery. We have PbO2 and negative is a Pb. Then we have connection nut bolts. These are actually generally copper but lead plated. Coating is provided on that. We have electrolyte dilute H2SO4, means pure water is added into the sulfuric acid, so that we have diluted H2SO4 acid is provided as an electrolyte. Vent plugs are there to release the gases which form into the battery, that is hydrogen and oxygen, that we have to release. For that vent plugs are used. And we have to ensure the percentage efficiency of any battery. So how you can rely on your battery? Suppose there is a failure of all AC supply and you don't have any backup arrangement. So in that case, you have only source, that is battery. So for that you have to ensure the efficiency of the battery. So for that there is a formula to calculate efficiency. C10 current means you are discharging your battery, suppose at 10 amperes for the required time. Suppose it is 220 volt, and whenever each cell reach its voltage after draining out 1.85 volt, then you can, in this way you can calculate the capacity of that battery. So these are the some of the reactions that happen at positive and negative terminals. So generally at this positive terminal oxygen released, and at negative terminal hydrogen gas released. And this is the hydrometer to ensure the that is the specific gravity of the your battery. So healthiness you can ensure there is a float inside this. So with this you can ensure just put this end into that battery, and you that liquid will come and it will shows the specific gravity of that electrolyte. In this way you can ensure the healthiness of battery. So these are the specific gravity ranges and how much your battery is charged. So that idea you will get from the specific gravity. Suppose it is in the range of this range. So it is your battery 75% charge. So like this you can, from the specific gravity you can say about the charging condition of the battery. This is the water distilled water plant which is used as an electrolyte for the station. Battery capacity that we calculated, it is a mandatory to have a battery capacity test once in a year, and for that you need discharger to discharge your battery set. We have to isolate battery from the system and then we have to discharge it. So this just by 20 ampere, if I am discharging 200 Ah battery set, then for the 8.5 hours, then actually it we can say 85% of its battery capacity. Then battery internal resistance measurement. It is there is a kit for internal resistance measurement kit is used to measure the internal resistance to check the healthiness of the cell, and it should be in the range of 0.1 to 0.9 ohm. Next we have charger maintenance. We have to maintain the charger, tighten the connections, we have to check all the system. And we have these two recent technologies, that is I already talked about VRLA, all regulated lead acid batteries. Nowadays we use a dry type of battery in our bike also, in vehicles also. Same technology is used here also in Ehv substations. We have wall regulated lead acid batteries, means the actually the electrolyte used in the paste form, not in liquid form. So that is the specialty of this wall regulated lead acid battery. And we have this now IGBT based charger, very compact technology, very less space it can take. And these are the different modules are there. If suppose there is one module fail, you can replace with this module with the spare one. So it is a switch mode power supply based chargers, SMPS based charger based on IGBTs. These are transparent tech. Even you can monitor the internal condition of your battery, as the glass type of these containers are provided for this. You can see inside the battery also. Suppose there is a visually also you can see the internal condition of the battery. And now a trend of their lithium ion battery technology, which is mostly used for electrical vehicles and for different application, communication, railways. There are so many application of this technology. It has we can say highest charge means duration of capacities, charging capacity, and highest rating can be achieved with this technology. Now we have a compressor system in many substations. As it is a air pneumatic circuit breaker, so you have to maintain the compressor system to maintain the breakers. Previously we were having a air blast circuit breakers, so for their operation we needed these compressed air. But nowadays everywhere these compressed, now the air blast circuit breakers are replaced with the SF6. So now there is no need of such system. Now we have what we did for the breaker operation of the breakers. We have used same if it is a air pneumatic breaker, So that we have actually installed separate compressors at local breaker level only. No need to maintain such system at your substation, but previously it was there. Again, we have to ensure the temperature of your control room, relay room, because there is a delicate, these are the power electronic devices or equipments or components. So for that, cooling is most important factor. So we have to use centralized cooling plant for the as an auxiliary system in any substation. So you may have split air conditioner, window type, but at industry level, you will having a air handling units, AHU based centralized AC plant. So gases are used nowadays. That is R series gases are used. That is a these are not affecting. That is a greenhouse effect is not creating by these gases. So this is all about air conditioning system. So these are different arrangements like compressors, heavy compressors were provided. If it is a bigger station, you have to make these means compressors you have to use. Then you have outdoor unit. That is a this is a tower, cooling tower. These are some of the indoor units. These are insulated so as to reduce the losses of the cooling. These are the outdoor units to cool the whatever that is coolant is there, that to cool it. So this arrangement is provided. Also in our substation, we have firefighting as an auxiliary system. In any station, everywhere we need fire fighting system, because there are chances of fire everywhere, whether it is a AC system or DC system. There may be the spark because of some abnormality, and because of that that there are chances of the fire. And to extinguish those fire, that we want fire these firefighting systems. So in substations, there are different types of firefighting arrangements are provided. Like we have generally these extinguishers, different types of extinguishers are used. But whenever you came direct across with the electrical fire, generally you should go for this. Whenever there is a fire in the panel, you should go with the carbon dioxide type of extinguishers, where there you cannot use water. Otherwise, there may be the problem to that person only who is handling that firefighting equipment. So for that you have to use CO2. So like this, if it is cable fire, then you can go for the DCP, dry chemical powder, and like this. So as per the application, so you should go for the using this fire extinguisher. Again, another arrangement we have in substation, that is a fire detection system. So there are different detectors which are smoke or fire detectors, fume detectors are there. So those will detect, and you will came to know here the zone where in which room, in which area there is a fire. So these are the detection system in the substation. Then we have for the transformers, reactors, we have these, especially we have nitrogen injection system for the fire protection of these costly equipments. It is based on the actually operation of particular protection for the transformers. Whenever different protection operates, and this system will operate, and it will inject, it will drain out certain level of oil, 1/3 oil it will drain out from the transformer, and it will collect it into the sump, and nitrogen gas will be injected into that transformer, so that automatically oxygen will not enter into the empty space. If oxygen enters, it will catches the fire. So to restrict that, we enter this nitrogen occupied that space, and in this way we protect our transformers from the fire hazard. So this is a nitrogen injection system. And yard lighting, this is also most important whenever you work in any EHV substation. Suppose there is no proper lighting, and in emergency we have to work at night also. If there is no light, there may be the chances of accident also. I have in my career itself, I have experienced this fact. Because of the less light in the switchyard at the starting of my career. So actually I have seen one accident in the EHV station itself. So because of that less light in that, just we were working on one focus light only. So that was, there may be the many issues. So a yard lighting is most important, and also it protect the theft also, because people are miss nowadays anything can be happen. Whenever you are these C isolators are open, one thing happened in one of the station. Generally we kept C isolators open, that is auxiliary bus isolator open. So thieves have what they did, they have opened the isolator blades in the open condition, and they have stolen the blades, because there is a much more copper to that blades is there. So in this way theft can also happen. So that for that you have to your lighting system also should be there in your switch yard for working as well as to protect from the theft. And general upkeep of substation, if you see it, we have to maintain the substation record, then maintain the cleanliness of the substation, all rooms. Then again we have to update the single line diagram, firefighting system, first aid. You should have first aid in your station, because we cannot move any person who has uh, uh, come across with any accident. So we cannot immediately go to the doctor. So we have to maintain the first aid system also. Healthiness of communication system, and if even you can think for the energy saving activities in your station. So these are the general aspects when you maintain any auxiliary system. So I want to conclude at the last, that is we have taken the brief overview of all the auxiliary systems present in this EHV substation, that is the AC supply, DC supply, yard lighting, air compressor system, air conditioning, firefighting system. So within this less span of time, I have tried to share as much as possible. And these are the some of the references which I used, some of the manuals, and from the Google platform also I use. So if you want some more information about this topic or any other, you are always welcome. So I'm thankful to all of you for this webinar. And this is I want to share some different activity which is most important for industry and academia. So we have formed one academy. So under this we have engineering student forum. It's ISO certified. So we have started this activity to connect industry people and as well as to the academic people. So we have formed one for the professionals. We have formed All India Institute Industry Forum, and for the students we have formed Engineering Student Forum. So under this we are arranging regular webinars, and also there are faculty from reputed organization for under this forum, particularly Institute Industry Forum. And here we give what is the advantage when industry and academia come. Now we are coming to know what are the openings, jobs openings are there. So many opportunities we are getting on this platform now. So if you are interested, you are most welcome. It is a free service. Anyone can join. And this is the contact details, my WhatsApp number, call number, and this is my email ID. So any professionals or even from a student also, they can join this forum. It's a free service and you will be definitely get benefited. And once again, I am thankful to organizer for this, for giving me this opportunity to express my this knowledge for to everyone. So now session can be open for the question answers. So I am just seeing these what are in chat box. What are the queries are there?
Students, if you have any doubt, please write us in a chat box. We will clear all doubts of yours. I repeat, all attendees, if you have any doubt, please write us on a
We have circulate this activity. Actually, we have near about 400 to 500 students across India are connected in this forum, student forum. So whatever that is any event came that we share into that group. So even all people will get this information. So it's a
Sir,
base initiative. I think there is a one query.
yes,
Gang
sir.
operating device. Okay. So what is in by gang operating device? Actually, it is another name for the isolator. Actually, isolator, there are two modes of operation of isolator. Generally at EHV level also, and even for the distribution side, you can use the isolators like if you can open isolators one by one also. Generally at 400 kV level, we open isolator with single isolator, means phase wise, we open the isolator phase wise generally, but you can open at a time also, especially at distribution side. We have a gang operating device. Gang operating means all three phases are actually you are operating at the same time. Just to, you open one switch, your all the three phases, that all the connection gets opened. So that is actually gang operated device, means you perform the operation of that isolator at the same time, means all three phases gets disconnected or you take out at a time. That is a gang operation. Any other queries? What is SCADA system? Yeah, SCADA is actually supervisory control and data acquisition system. You know that in any substation, now we are going for the automation of any industry. Even our all substations, we are actually going for the automation. So for that, SCADA is particularly is a human machine interface. See, we are human and we have to interact with the machine. Machine means all our these equipments. So actually SCADA plays vital role to communicate between machines and man. So that's why it is known as human machine interface. That is a SCADA system. Supervisory control and data acquisition system. Whatever signals are coming from the field that are taken through the data collecting unit DCUs, and here we will get into the that, but especially on the computer SCADA screen, you can monitor all your substation. Even you can control all your equipments from this, especially from the SCADA system. So that is a SCADA system. Any other queries? One question is there, how God means GOD, that is a GOD, gang operated device, is operated. Actually, see, whenever you work at a low voltage level, it is safe to open, but first you should confirm whether the breaker is open or not. Whenever you open any isolator, first you have to confirm whether the breakers three poles are open or not. That you have to check. If you open in that condition, if suppose one pole is stuck and you open in that condition, there is a huge sparking on that, and even accident may occur in that condition. First you ensure that your breaker is open, and then you should go for the with proper permit, that is by following all the procedure, then you should open your GOD, so that then it is safe. And generally it is advisable to open it at low voltages, but whenever your system is actually suppose it is a means all you have confirmed everything, then there is no issue. In de-energized condition you can open the GOD. Sir, what is VFD? Yeah, it's a very good question. It's a variable frequency drive. I was thinking about covering this aspect also in auxiliary system. In many stations, there are VFD also as an auxiliary system. Even UPS, uninterrupted power supply, that are also used in many substations. So variable frequency drives are actually, these are, we can say that application of power electronics into the power system. This is one of the example of VFD. variable frequency drive generally used to control the motor or any drive which you want to run from that system. So generally here we can say rectifiers are used, means you are starting or stopping your motor through the rectifier unit, means actually you are going for the soft switching rather than closing and opening the switch. You are going through starting and stopping of the your particular drive through the rectifier. It may be your it may be SCR based or it may be IGBT based also. So that is a variable frequency drive. And also the starting torque, or we can say starting current, is taken by the system is very less, and there are not chances of any over voltage and anything into the system, means faults are also can be minimized by using the variable frequency drive.
Sir,
It's
next question is there. What is CVT?
What is CVT? It's a capacitance voltage transformer. Generally, we use CVT at 400 kV level, and up to the 220 kV level and below level, we use potential transformer PTs to measure the voltage level. Actually, we use bus PTs for the 220 kV and below level, means common PT supply we give to all the feeders. But here in EHV at a 400 kV level and above level, we use individual phase wise CVT, capacitance voltage transformers. These are actually, we divide this voltage across the resistors and capacitive arrangement, and then we are going to measure the voltage, means we reduce the voltage and we measure. So that's why it is a capacitance voltage transformer. Any other queries?
Any other queries, students?
Okay, about one query is there. I am from JBE. It's an enterprise which does all cable laying works, HV, EHV, 220 kV to be done to contract. Okay, it's a good
It's
thing
not a
for,
query. Yes,
yeah,
he
yeah,
shared
it's
his
an
work.
advertisement actually.
Yes.
Okay.
Uh,
Another query?
is any doubt, students? You can write us in the chat box. What is a DCS system, sir?
Uh, DCS. Can you tell me the exactly full form of this?
What is a digital control system?
Okay, digital control system means, see, we are now moving towards the automation of even power industry also. So everywhere you want now, that is a digital control, especially for the control, you will have we can say controllers, like you have different types of controller you learn into the our control system, that is PID and all those things. Such type of that is especially we take when the take the use of specially digital electronics into the power system, especially for the control and protection. Then it is actually a DCS system, digital control system. So that we use especially for controlling, and even for protection also you can use this system, because our many relays are based on the electronics. Especially if you see previously that was the electromechanical and all the moving part relays were there, but now these are relays are static, means all electronic components we are using. So that we can, it's a DCS system.
Sir, there is one more question, that is, which is the best company in manufacturing on-load tap changer of transformer? You will suggest.
Actually, see, you have to go for the brands. There are actually the agencies which are actually we can say, especially Crompton Greaves, Yamco Transformers. There are many more companies are there. Generally, these they are manufacturing their own these on-load tap changers also. So if we go for the brand, that is, we know that the feedback of these companies, if you see in industries like these, really we have some good feedback from such companies, branded companies. So online tab changer can go for that also.
And next question is, what is the maximum number of tabs available in market? Tab changer transformer
Uh,
available in.
it 19 numbers of tabs that are available, but nowadays more also going on things, that is the, but at max it is a 19 numbers of tabs are there in the market.
Next question is from Sai K. Which company manufactures best power cable according to user?
Best power cable industry. Yeah, he has given option also.
Option
K,
also. Yes.
UCL, phenolics. Actually, it is really tough to answer or comment on such. Actually, means whenever if you use, actually, then we can say the it's actually quality, because there may be sometime manufacturing defects also somewhere remain while manufacturing, and we cannot directly comment on this, that is which is best, or but you can just go for the checking the feedback. You now there are online systems, you can go for the checking the feedbacks of this before purchasing it. You should always read the reviews and feedbacks, then you should go for this. But you should always prefer branded, because there will be the warranty and guarantee on all those things, so you should always go for the branded product.
Next question is, what is rated operating duty in breakers?
Yeah, these are the actually we can say specially these are the opening closing cycles, because it is most important your when your breaker close, if it is in closed condition, at which instant it should get open whenever there is a fault. So in that condition your breaker should gets open, so that those the sequence of getting breaker open, and after that suppose there is another fault, that is a transient nature fault. In that case there is a auto reclosing option also. So in that particular time you should breaker gets again open also, close also. Otherwise, if breaker remains open and it is a temporary nature fault, there is an interruption. So this duty cycle we have to maintain, and especially whenever there is a time comes for the specially opening, it should be in milliseconds. So that may be vary for the this closing of the breaker. Then another query is, what is the most important thing in breaker? So especially for the breakers, actually most important thing we can say that it's a specially its operating mechanism. If operating mechanism is not proper, generally there is not means the pressure of that SF6 and all those things, generally it remains maintained, but the control system which operate that breaker, that should be in a healthy condition. So all your that whatever circuit closes whenever opening of the breaker, that all interlocks will be get fulfilled. Means your control protection circuit
Well,
will be through. Then and then it will operate the breaker. So for that, all the contacts like pneumatic breaker, oil pressure, all these quantities get fulfilled. Means your control circuit should be fulfilled, then it will be easy for the operation of the breaker. Okay, any other queries? Today I have actually another session also. We have today another session from 1 p.m.
no more queries. I think right now no more queries are there.
Yeah, yeah.
Okay. As
Um,
now we come to end of the session.
Aparna madam, just a minute.
Yes, sir, yes. Sir.
Before you are going to the vote of thanks, I just want to appeal all the students, engineer Santosh Kaware sir having, passionate to interact with all the students and particularly student community. And I have remember that we met him while we had a visit in I think Kadava. That
Yes.
time Kaware sir only guide us and show all the Kadava station, and because of his passion to interact with the student, he has made this student forums. So I haven't seen such a good initiative taken by working professionals in state electricity boards. So I appeal all the students, please join this forum. Definitely you will get lot of additional informations, knowledge, and you can connect with yourself with the actual industrial people, those who are working in the core company. So it's my appeal, sincere appeal to all the students, you know just you will have a very good forum. Just join it and take a benefit of it. And really very good session. We all are really thankful to you, sir. Thank you. Yeah.
I am
Let's.
also thankful to all of you and your institution also for this giving me this golden opportunity and this platform to express my knowledge. So I am really once again thankful to all.
Now it's over to you, Aparna ma'am.
Okay, okay. Thank you, sir.
Thank
Now,
you.
as we came to end of this webinar, I really would like to thank Mr. Santosh Kaware, sir, for accepting our request to give a webinar on auxiliary systems in EHV transmission system substations. This is very informative session, sir, and students also enjoyed it. And very informative session you have discussed, as well as the forums which you have started for the students. Definitely, I assure you from our student that, sir, definitely our all students are going to join this forum, and they will uh, get a time to time guidance from you through that forum. Thank you very much, sir. Next, I would like to thank our principal, sir, for continuously motivating us for organizing such a webinars in a department for students as well as faculties. And from bottom of my heart, I really want to thank you, our beloved Honorable HOD Sharad Patil, sir, for motivating all faculty of our department and encouraging us and giving time to time support to us for arranging such as webinars like MOUs as well as a next guest lecture, etc. Your all motivating words encourages us, sir, for arranging such a things. Again, I would like to thank all my colleagues who work with me and who help me to arrange such a webinar. I thank you all. And but not in the least, lastly, I would like to thank all the attendees to make this webinar great success. I hope this will encourage, I know this is encouraged us, and in future we will arrange a same seminars too. I also like to thank all the uh, teaching, non-teaching faculties present in a NBN SSUA. Okay. Now I formally announce that today's webinar is ended. Thank you, sir.
Once again, thanks to all of you.
Thank
Thanks.
you.
Thank you, sir.
Thank you. Thank you.
Now one instruction is there for attendees. I have shared a feedback link in a chat box. Please everyone go through it, fill it, and you will get your certificates. I have shared a feedback links in a chat box. Okay.
Okay, thank you, madam. Thank you.
Thank you.
Sir,